So we are finally at that point to start wiring the layout, I guess middle deck. And you see I have these Railcom boards that I built, and it's been very easy actually, because I didn't have to solder any of these things. In the past I did, on the previous iterations of this board, because they were all SMT components, but then I realized that why not just pay somebody to do this professionally on a machine so that I don't have to spend an hour per board, and I have 40 something boards that I need to do. So there they are. I think I've shown these boards before. In any case, the big pieces like the RJ45 connectors and these terminal blocks and the capacitors, I soldered them. But everything else, the SMT components, they're all soldered by machines, because it's much faster and you can just order a batch and it's just done fast. So you can see, I have a setup here that I can still do SMT soldering, and I have a station and hot air and whatever. So, but these are the boards. These specifically are going to the Helix. I need 3 of these for the Helix, and I have 2 actually for the rest of the approach to the Helix and whatnot, because there is also a block before the Helix in the staging that I want to detect. Well, I want to detect all of the track, every turnout, every piece of track, because why not? I custom built this and I already paid for it, and it was much cheaper building than buying. Okay, let me rewind that. You can't buy it yet. Depending when you watch this video. Maybe some Railcom LCC boards are already available. I know other circuits was working on one, but at this point there aren't any, and these custom boards are the only things that are, they're custom. So 3 go to the Helix for double track, up, down, whatever, so every loop of the Helix gets detected. And then these are going to go to the main deck, and then I'm just continuing to build more as I go, and then daisy chain them into the LCC network. And hopefully we're going to have some trains running someday soon. Trademark. Very soon. Anyway, I'm going to stop here, and then I'll update you with more things as they happen. I thought maybe would be interesting to show this. I don't know how many people would be interested in nitty-gritty electronics parts of this hobby, especially with the LCC, but here it is. So I have one of those new boards here, and you can see the node is 0C. It's just brand new, and brand new as in nothing has been done to it software-wise. So prior to this, I've programmed a bootloader. Okay, I guess I should say something was done to it. I put a bootloader on it. The way it works is that the microcontroller has a portion where you can install a bootloader into it, and then every time you power it on, it will initialize that bootloader, and then it will allow you to do programming through the network rather than having to use chip connections like SWD or whatever. So program it through the LCC network, right? So as long as the bootloader is there and the system can boot, and you can see like the power LEDs and so on, as well as the indicator that the system is powered up and the bootloader is active. So once you initialize the bootloader and everything is fine, then you would see the node in the list, and there it is, 0C. It's this one there. I've just powered it on, but there is no configuration, there is nothing on it. It's just waiting for the actual firmware to be uploaded. Now the benefit of having a bootloader is that you don't need to program any of these nodes directly. You don't need to be on the ICD port or ICD pin out here and then connecting one of these ICD debuggers. So this is what I've used. These boards are based on Texas Instruments chips, TM foresee 123. They're older chips, but they still work. So, and that's basically what I had started with. So this is one of the Texas Instruments launchpad boards, and basically it has two of the TM4C chips, 1, 2, 3. One is the actual chip itself that you can program and do things like learn. This is a launch pad, so it's like a learning platform. But then the other chip is the debugger, and it acts as an interface between a computer and the chip you're programming. But really it's the same chip, just as a specific firmware on it. So when you set it up in the debugging mode as an ICD or in-circuit debugger, then you have, you know, several data lines that you need to connect to the client or the chip that you want to program. So that's what these pins are here on the board, and then you have these pogo pins that connect to it, and that's how I programmed the bootloader. Now I don't need to program the firmware through the ICD, the in-circuit debugger, because I can see now the actual node in the LCC Pro here in JMRI. So we're going to do the firmware update, and we're going to pick that node, OC, we're going to say select, and where are we going? Oh, I think we're going to C temp, and we'll pick the C. So the way that this works is you have to okay, well, I'll rewind back. Bootloader has a checksum, and the chip checks the checksum, and so you need to sign it in a sense programmatically, and you need to assign it a node ID, the LCC node ID, in advance. So the bootloader for this board, as I said, node is OC 0C, and so your bootloader needs to be programmed with a node ID built into it with 0C, so that when you pull it up here in JMRI LCC Pro, it will identify itself as 0C. So, you know, hey, I'm here, I'm 0C, send me something. Your firmware has to also be 0C to match the bootloader. The bootloader will check the firmware, and it will not accept the firmware that doesn't have the matching node ID. That sort of prevents you from uploading a wrong firmware to the board and then really hosing it, especially if it's already installed someplace on the layout. So as long as you can put the board into the flash mode, then you know you can flash it. And some boards, so these are all software features, right? You can put the board into a flash mode, or if you programmatically code it, the moment you start flashing, the board will recognize, the bootloader will recognize that you want to flash it, and then switch to the flash mode and then allow it to program it. These are all software features that you program into the nodes. Like it doesn't really come with it by default, unless you're using OpenMRN, right? I mean, that's already part of the OpenMRN ecosystem or the API. And OpenMRN is the Open Model Network, or whatever, the stack that is being used now. Some people have programmed their own LCC stacks, and they're available on GitHub, but OpenMRN is like a longest running project that's been around since, I don't know, 2012, maybe 2015, a long time. And it's in active development. So it supports now, I mean, you know, STM32 chips, it supports the ESP32, although you have two different versions of it. You have the single thread OpenMRN, which is OpenMRN Lite, and then you have the full OpenMRN, you know, that's generally used by vendors to create products, but you know, I'm using this because Balazs made this board, and then I was able to get the board schematics and stuff through him and build the. Balazs is one of the developers of OpenMRN. So, anyways, so let's just see if the board automatically switches to flashing mode, or do I need to restart it? So basically, if you tell it, well, I want to do this, and I'm 0C, you say load, you can see that it's updating the firmware. I didn't have to press anything, but that's because the board's bootloader had an LCC connection, and it's waiting on the LCC bus, basically listening to packets and traffic. And so if it sees the traffic from a JMRI that you know, you're telling it, hey, I want to flash, then it will switch to that flash mode. And now once completes, you can see that now the node's initialized, and it says Railcom IO board, open LCB browser, custom hardware, and the board's alive. And so now if we close it and refresh LCC Pro, you can see the 0C node is now live with all the things, and you can see it here. So basically that's how it works with this specific node. If you build your own nodes, I mean, you can use OpenMRN, you can use OpenMRN Lite, you can use some of the other libraries that people have written for different microcontrollers, and some of them might have these features, some of them might not, but it's very convenient, especially when you have a board, you know, someplace on the layout that you know, it's inaccessible, like, you know, well, that's kind of accessible, but you know, underneath the bench or whatever, and then you can't really get to it physically. Yeah, like there. I mean, I can stick my head underneath there, but I mean, I can't see much there. So, you know, something like that. You would just call up the node based on its address and then flash it. And then now, I mean, you know, I don't need to demonstrate a different node ID and how that flashes, or how it prevents you from flashing or fails to flash a different node address. So either way, it's like a safety feature or fallback. And that's that. I mean, I don't know if this is interesting to anybody, but it's, you know, LCC is rocket science, so it's a magnitude. I'm saying this. LCC is a magnitude more complex than DCC because you have a full networking stack here. I mean, you know, you're on Cat5 CAN bus, and with DCC you only have 2 wires and everything is modulated into the DC signal. Here, I mean, you have packets, you have, you know, node addresses, and you have multi, you know, broadcasts and stuff, and, you know, almost like MQTT in a sense. It's harder, but hopefully, I mean, you know, it will become more accessible to everybody as time goes by, and this is where the things are going. And, you know, DCC still works. I mean, this is just for right now, people who want to embrace new technology and have more abilities, or to have more control over their layouts. I mean, because, you know, this node can do anything, whatever you build into electronics, and they don't have the issues of DCC, of limitations, how many devices you can have on the DCC bus. Because eventually, I mean, you know, how the way it works is that DCC has a specific frequency, and the frequency equals how many packets you can, I'm simplifying, how many packets you can squeeze into the signal, right? So I think that the general accepted limit, I think, was like, I mean, you can have, I don't know, 14, 15 locomotives, and then things really grind to a halt because you just can't put any more DCC commands into the signal. There is just no room to embed anymore because you use it all up. Well, there is not such thing with LCC because it's full network and it's switched and whatever. I mean, it's a broadcast to all the nodes, and then, you know, if you don't care about it, you don't listen to it, because all of these nodes only care about stuff that goes to them, right? If they're consumers of something, they will listen to, you know, producers of those events that are directed at them. And then the bandwidth of LCC is much wider, bigger, I mean, than DCC as well, because, like I said, it's full network. Well, I guess, I mean, I'll just leave it at that, and then if I come up with something more interesting and easier to comprehend, I don't know, I'll record it. If you have any questions, just drop them in the comments. I mean, you know, whatever I know I can share. I mean, it's not, I'm not holding back on anything here. I hope you see that. I don't know everything. I mean, you know, I'm sort of like here, neither here. I'm not I'm armchair expert, not unlike the developers of OpenMRN. I'm also a user, so I mean, I don't know in-depth OpenMRN API like people who actually write it, but I can find my way around it, and that's how I got to this. So anyway, I'm rambling now. I'm gonna close it here, and then we'll see what happens next. So here we are on the floor, doing everyone's favorite part of the hobby, wiring. Of course, you gotta have your safety sandals on. That's homage to Otter Creek and Rio Grande. And I wanted to share this with everybody, I guess, and document it for myself, because it's a peculiar situation. This is the, let's call it the main panel. I mean, it's an orgasmic level of concentration of electronics in one spot, in a small footprint. TCS command station, LCC, CS105, 4 Railcom LCC nodes, block occupancy detection, short circuit protection, and track power on off per each line. There is 6 lines on every one of them. There is RF circuit signal LCC here, 4 PSX-ARs, and a custom ESP32 node, which serves as a CDI editor, the configuration description information editor. So CDI is the configuration sheet for every node. All the parameters get stored there, and so you can edit it. Generally, you would use it in JMRI, right? You would load the CDI into JMRI and then edit it there, or LCC Pro. But this node lets you connect to a web URL, internal one, on the Wi-Fi network, and then you can configure, you can pull up any node on the LCC network. So not just this panel here, but anything on my network. And then configure it. This is Mike Dunstan's ESP32 code and stuff. So I managed to persuade him many years ago to make this. I don't know if the code is public or not, but here it is here running on my layout. So I wanted to document this situation because it's kind of peculiar. I have 4 PSX-ARs here, and I just noticed that I mounted this one backwards. I guess I have to change it. So what happens here in the staging, I'm just going to move you up here. I don't know if you can see. I have a interlocking. So the Helix has 2 tracks, right? And I wanted to have ability to have trains cross from one to the other. Not like you would, but I wanted to have an ability. Now the thing is, the phase of these tracks is different. So let's say this is red and this is green, and then this is green and this is red. So they're flipped. So if you were going to interlock them here, obviously you would have a short circuit, so you have to have an auto reverser. Well, the whole section of track all the way to the end there is actually one auto reversing block, including the turnouts. This was prior to occupancy detection, but it still required a PSX-AR. And for a few days, I mean, you know, was racking my head about it, and then I went to the forums, and ultimately Balaj came up with a solution for auto reversing, which was kind of ideal. But this was prior to me using Railcom block occupancy detection, and I think he noted that I can't use it in one configuration, I can use it in another. So one configuration is that the PSX-AR has to be ahead of the Railcom block occupancy detection, because these boards have also short circuit protection as well. They would trigger before this would flip. And obviously, if you had this behind this, then you would be flipping all 6 lines and not just the one you need to flip, the phase, right, of the track. So that's why I have 4 of these, because for 2 tracks I have one long piece of track all the way to the end and another one, so that's 2. And then I have 4 turnouts here, but these 2 are going to be one block, and that's going to be one block. And then I don't know if you can see it, but I guess we can't, it's kind of dark. And then there is a turnout here, so this one is not being auto reversed, because I think this is the base polarity, you know, red here and green here for me. But the other ones need to be reversed, and you know how when you reverse, I mean, your whole section has to reverse because the train needs to fit there. Otherwise, then you're gonna have a problem. So when you hit the section that needs to be reversed, then the entire section all the way to the end will reverse, and then train will end up where they need to be, like in the other side of the track or railroad, and then the polarity will switch. So anyways, I wanted to put this on video because, you know, I realized that I forgot what the settings were for these PSX-ARs, and I have to go back somehow and read the forums now to see if I actually wrote down what the CVs were, because I had to change the CVs on these as they were triggering either too fast or too slow, and then causing a real short rather than a reversing. So, you know, one thing after another here, and you know, in hindsight, obviously I should have documented, but I didn't. And you know, this is just getting more and more complicated. Although, I mean, there is no real documentation yet. I mean, once I start assigning the blocks on the nodes, then I obviously have to document what's what. So on the terminal block here, I mean, these are the loops. So first level, second level of the helix, third, fourth, fifth, sixth, seventh, and eighth is not there yet. So that's how many loops I have. So each loop and each track on the level, basically the two loops get separate detection, and then there is an isolation here. I can't see it, but there is an isolation between the loops. So when you come out to the next level from there, obviously, then that becomes a new block. I don't know if that's really necessary or not, but I have the boards, so there it is. And so next step will be to finish the wiring here, and I need to change the wiring here because I was connecting both the track and the turnouts together, and now I have to separate them. And as I mentioned, that's why I need 4 PSX-ARs. If I had just the turnouts and the track in the current configuration together, then I would only need 2. But then I wouldn't know when the train is actually cleared the turnout. Because obviously, I mean, if they're powered from the same area or the same line, and then they go to the same line detection, then you only know about one. Meaning the whole thing and not one or the other. And I think for purposes of automation, I want to know when the train has cleared the turnout so that something can happen. Or when the train has fit into the block of the track and then approaches the turnout, and then, you know, before it triggers the turnout. So either way, I mean, it's one of those things. And luckily, through another serendipitous you know, sequence of events, I had another 2 PSX-AR, because I have to put one more here where those wires are for this track here, because that's also a reversing. This is a bypass loop. That was not planned originally. I mean, this was a feature that we added later, so that I can run trains in a loop on the first deck without having to have the upper deck, so middle deck here, rather than having trains go all the way to the top, because I don't have track there yet. Well, nothing is powered here yet. Obviously, you can see all the wires are hanging. So that's what I'm working on. I mean, that's where we are right now, and I'm gonna continue doing this fun stuff and document the progress. And if you like it, stick around. Okay, so let's recap what we've got done so far. Pen Central. A main control panel that looks like a Christmas tree. Check. Well, actually, I think I made a mistake on these LEDs. They're very bright. These are the original ones, but I should have used larger resistors, higher ohmage, so that they're darker. Because once you put them underneath the benchwork, they're gonna be illuminating down a lot. So the nodes will end up here and whatever else, and it's gonna be really bright. Maybe I'll just put a piece of tape. I don't know. Anyway, I've got 4 PSX-ARs installed and 4 nodes, the Railcom block detection, and so the PSX-ARs are the interlocking here at the, as I mentioned in the staging before the helix. We're at the helix here. And then all the nodes are detecting the helix and the interlocking and whatnot. So I guess I can call that done, more or less. I think I still need to program. What happens is that because these nodes have short protection, and that's basically a short detection, they're kind of competing in the interlocking. So I need to reconfigure the inputs on this node actually, because that's the one that's connected to the PSX-AR. I need to configure this one to be more relaxed on the short detection, at least for those 4 inputs. And then it should be okay. Because I've noticed that the locomotives sometimes trigger, it ends up being a race condition. So yeah. And thus, I guess we can call that done. And then next thing is gonna be getting all these wires finally connected with new nodes, and everything else. And speaking of new nodes, it wouldn't be me if it doesn't go overboard. So here is another 10 nodes waiting to be installed, programmed and installed. So they're gonna go for the main deck, I guess, or the middle deck. So 1 here, 1 there, 1 there, 1 there, and so on, and then you just daisy chain them together in the LCC network. I think that's the whole idea about LCC. Most DCC setups, or larger ones, are centralized, and then you run long, many wires to whatever. With LCC, you are localizing your things, and detection and whatever is here, and it's there, and it's whatever. Sometimes, you can do that with DCC, but I think the next step, what's missing here with LCC, is that there should be boosters built into all these nodes, or at least there should be a super node. I guess no manufacturer would make that, but DIY people might. So let's say you have a super node, and this super node will do, like this Railcom detection, and it will do signaling, and it will do everything. Well, this one does signaling because it has a signal bus. Balazs made a signal bus, and you can connect signals and push buttons, and you'll see this when I actually hook all these things up. So it has a Railcom, but I would add a booster, or not a booster, but like let's say a 1 amp amplifier for DC signal, because you get the DCC raw signal here on the LCC bus. So you could technically boost it or amplify it and then put it on the outputs. That way you don't have to bring another set of 12 gauge wires that we normally run on the layouts, like I have it here, but of higher amperage to drive the actual engines, locomotives, right? So these local nodes would actually power their respective segments, the blocks, right? And so you wouldn't have a centralized location of your command station like we do here, and then long DCC bus, and then having to contend with all those things, and then like you have to splice it, you have to do either those T connectors or whatever, or however you connect the feeders. Well, you wouldn't. You would just run an LCC bus and the power. So that's 1 bus less, I suppose. Because I don't know about you, but I've ran also accessory bus power, 12 volts. So let's say you only run LCC cable, which is Cat 5, and then you run another accessory bus power, 15 volts, let's say. And then you would plug the 15 volts into the super node that will do everything. Create DCC signal and do occupancy and signaling and everything else, all on this one board. Matter of fact, I would make this modular, so you can sort of add daughter cards and then pick and choose whatever you like. I haven't had a chance to do that yet because, I'm building a layout. Maybe another iteration of this layout or another layout might have that if I ever get a chance to do more DIY electronics. In any case, I'm gonna, I guess, continue with this theme because that's where we are. As I said, everyone's favorite topic, wiring. And I want to get this line, at least the main line, hooked up and running. I want to get trains going because that's what's missing. Everybody shoots to get their trains going as fast as possible. Here, I've been doing one thing, then another thing, then another thing. Everything has to be completed to the T, and then next step comes. And really, should have been, targeting getting the trains running as fast as I can, just to keep the interest going, because it's been a long time since I've done anything here because I didn't have any interest. In any case, that's it for now. We'll see what happens next. Maybe there is another video after this segment, maybe not.